Okay, now in this question we're being asked to, basically it's asking us an understanding of the species in solution. You need to have some understanding of dilution and how to do a calculation on that to work this out. So it's a titration between sodium hydroxide and hydrochloric acid. So at the start we've got hydrochloric acid. Now the hint below that it refers to is that it may be useful to put a table together and work out the relative concentrations, and obviously from that you should be able to plot some kind of graph. And it's assumed that the total conductivity in a solution is the sum of the conductivities of the ions present. So you've been given some information in there. So we'll put together some kind of table and see how we go on that. Now we've been given some information on the relative conductivity. So chloride and sodium are equal to 1. Hydronium ion is equal to 5. And so we'll look at that with each in turn. We're not given a volume, so we can just work that on an assumption of a volume. So let's have a look. Now with most titration curves we're normally interested in the start, which is the initial, and in that case what would we have present? We'd have the hydrochloric acid, and we know that's going to dissociate in water, and that's going to produce H3O plus ions and Cl minus ions, and the H3O plus is worth a 5, and the chloride ions are worth a 1. Should have done that a bit better, but anyway. Now, in fact I will. Right, now half equivalence point. Now if we assume we have say 20 mils of HCl, just an assumption, and it's obviously a one-to-one stoichiometry, so that means if we have the same concentration, halfway to our equivalence point we've added say 10 mils of sodium hydroxide. So that means we've got a total volume of 30 mils. Okay, now that means the sodium hydroxide, we've got sodium ions, and there's only 10 mils of those, so that's 10 over, so the actual volume that was added over the total times by the concentration, which is 1 mole per litre, so that means it'll be 0.33 sodium ions. Now the hydrochloric acid started at 1 mole per litre, and so I was going to write 1 mole per litre. There was 20 mils of it. The volume, total volume, is now 30, and that means we would have a concentration of 0.667 moles per litre, because it's not going to do any reacting. Now the acid volume itself would be 1 mole per litre to start with, and in theory we would basically do the same calculation, 20, and it would be 2/3, but it's also been half neutralized, so there's only half that concentration. So instead of being 1 mole per litre, we should put that as being, so we're basically putting it at 0.5 because it's been half neutralized. So 0.5 times 2/3 equals 0.33. So it's 0.33 H3O plus. Now equivalence point is a bit more straightforward in that sodium ion concentration now would be equal to 0.5, because we're going to have basically half, 20 over a total of 40, so, and the same would apply to the chloride ion concentration. So just a minute, I'll just make that clear. So it's just halving it because we've put, equal volumes together, and 0.5 chloride ion. Okay, and from there, at twice the equivalence point. Now the reason we choose twice is it just seems to be a standard after, because obviously titrations are finished at equivalence point. But if you're interested in what the pH does after that point, it's typical to go twice the equivalence point. So it's going to be 40 over 60. So that's 2/3 of 1 mole per litre, and that means we'll have 0.667 moles of sodium ions there present. And the chloride ions, they'll just keep on going down because they're not reacting, but we're just diluting them further. So we started with 20 mils, and the total volume is 60 times 1, and that would leave you with 0.33 chloride ions. Okay, it's starting to look a little bit messy. So as long as you understand how to do these dilution calculations, it's not too much of a problem. The excess hydroxide, so it's going to be 20 over 60, because this is the amount that you added after equivalence point. Okay, so that didn't react. So 20 times over 60 times 1 equals 0.33, and that's the OH minus. So now that we've got the kind of concentrations, we've got the numbers for the relative conductivity, we should be able to get some points together and plot a graph. Now, because the sodiums are just worth 1 in relative conductivity, the concentration, fortunately for us, is just going to be equal to that. So for all the ones that are just 1, like these ones, those numbers will be the conductivity. So there's sodium, there's chloride there. Now, for the H3O plus, remember that was worth 5, so we'd have to multiply that by 5, and that would be like basically 5 times a third, so it would be 1 2/3. So it would just be 1.67, and the hydroxide is worth a 3 relative conductivity, so 3 times a third, it's going to equal 1. So from that we can get a total conductivity, and that I'm just going to write on the left hand side. I know this is getting a little bit messy here, but that means a total conductivity would be 6 in this case, 5 and 1. We've got 0.33 here and 0.33 there, so that's, and we've also, but that's times by 5, sorry, that's going to be 1.67 and 2 lots of 0.33, so that's basically going to be, that's 1 for those two adding up, and plus that's going to be 2 2/3, so that's 2.67 is the total conductivity there, and that's obviously just going to be equal to 1, and at the end here, and the bottom one here is equal to 2. So that's a relative conductivity in total at each of those points. Okay, so if you're careful with your dilutions and your calculations, you should be okay on that point. Now it's time to put that into some kind of graph. Now I've just put those points in on this graph. So this is just the total conductivity, and I'm going to draw in some awkward thing to show a line there to show how the conductivity varies. And basically it asks you to discuss what's going on here, and that's really kind of the easy part, where you talk about why the conductivity is high at the start, because the H3O plus, the HCl dissociates completely. We get a high amount of H3O plus and Cl minus ions, and as it proceeds, so we've got high amount there of this and this, and then as it proceeds, the NaOH that reacts and with the H3O plus, and therefore it reduces, but it's also being replaced with a sodium ion at the same time, but that's affected by dilution, and it's not as good a conductor. It's not as good a conductor anyway. So therefore get a reduction in conductivity until finally at equivalence point, where we've really only got at this point sodium and chloride ions. So really the H3O plus is steadily declining through this area, and then it slowly starts to increase, because what we're doing is obviously we're adding OH minus. Even though we've got the dilution there, it is a better conductor than the sodium and chloride ions. So that's really discussing that question there, and that's that question done for the first part.